In this demo, we'll get rid of the pagination links in the custom header and add them as HateOS links. We're looking at the create links for authors method, as that's the one in which we will create these links. Let's accept an has next and has previous Boolean value for next or previous pages. We can now put the previous and next links in the links array. If has next is true, we add a link to the next page. And likewise for the previous page if has previous is true. On to the get authors action. First, let's change the pagination metadata. Generating the previous page link and next page link is no longer necessary. Generation can be removed, and the previous and next page link can be removed from the pagination metadata itself. We create the links by calling our create links for authors method. This time we additionally pass through authors from repo.hasNext and authors from repo.hasPrevious. And that's it. Let's give this a try. We've still got our request from the previous demo lined up here. Let's send it. And if you look at the response body and scroll all the way down, we see that we now have a next page link. We're asking for page number 1, so there is no previous page link. And let's have a look at the xPagination header. This no longer contains these links. Now let's try an ordered, searched, filtered, paged, and data-shaped request. And this, again, works as expected. Everything we've done up until now combined into one request. We now know how to add HateOS links to resources. But we're still missing something. The root resource, in other words, the links the consumer will get when accessing the root of your API. Let's add support for that in the next demo. In this demo, we'll add a starting point for consumers of our API, a root document. From that root document, the consumer can learn how to interact with the rest of the API. This document will live at the API root, so host/API. Let's add a controller for this. It's an empty API controller, which we will name root controller. Let me paste in the basics. We only need one action in this controller. Let's name it getRoot. It should be executed on a GET request to /API. So we'll use the HTTP GET attribute. /API is covered by the route attribute, so we don't need to pass through an additional template to HTTP GET. We will immediately give the route a name, as we'll want to refer to this when creating the links. So let's generate these links. What we want to generate are links to the document itself and links to actions that can happen on URIs at root level or that are not accessible otherwise. In our case, that means a link to get to the root document itself, a link to get to the authors, no link to get to the courses, as courses are children of an author and can be accessed via that author, and lastly, a link to create an author. Finally, we return the links with a 200 OK status code. Let's give that a try. I've got a GET request to the root lined up here. Let's send it. And that almost looks okay, but apparently we don't get an href value for creating an author. Let's switch back to our code and solve this. I'm referring to a route named createAuthor, but I forgot to name the route. So let's fix that by adding a name here. And let's give that another try. Let's send this request again. And there we go. It now works as expected. From this root document, consumers of the API can start interacting with the API. They can get all the authors. And seeing that returns links as well, from here they can continue navigating through it. So this looks kinda good. We've just implemented HateOS support for our API, and as you've seen, it is not that hard to do. But this isn't right. We're looking at that authors resource again. We are now always returning these links. But should they really be part of the resource representation when asking for application JSON? This feels like a lot of overhead and bad for performance. Well, we already learned that what we're doing now isn't the completely correct implementation. To fix this, we will have to dive into advanced content negotiation and media types a little bit deeper. That is coming up in the next module. But first, let's have a look at some other options and the module summary. There's other approaches we can take than what we did in this module. There are efforts on the way that describe languages for link representations. And there's even efforts to include the media type descriptions in a resource representation with links, so we would know what to send to, for example, update a course. That avoids the need for separate documents documenting it. Let's have a look at a few notable ones. The first one is HAL, or Hypertext Application Language. It provides a set of conventions for expressing hyperlinks in either JSON or XML. So it's a standardized format for those links. And I'm a big fan of adopting standards, but this one has never left the draft stage and has expired since November 2016. Another notable one is Siren, or Structured Interface for Representing Entities. It includes a way to format the links and a way to describe what to send to those links. It's currently at version 0.6.2 and there hasn't been much development on this for the last few years. There's a .NET implementation available via the link on screen, but it has the same issues. And there's more. There's JSON LD, a lightweight linked data format, and JSON API, a specification for building JSON APIs that also includes a way to represent links. And there's another one, and that one is an Oasis standard, supported by big vendors like Microsoft, SAP and others. It's named OData. But OData goes way beyond just HateOS. It's an effort to standardize RESTful APIs. So it doesn't only cover HateOS, it also includes rules on how to create URIs, how to page data, how to call functions, how to work with batch requests and so on. And these aren't even all of them. There's quite a few others. In other words, given the current state of things, it's not that easy to decide on which one is best, especially since most of them aren't yet standardized. Let's have a look at this module's summary. This module was focused on HateOS. Hypermedia, like links, drive how to consume and use the API, and the functionality of the consuming application, its state. A good example would be a piece of functionality that allows someone to make a course reservation. Without HateOS, the consumer of the API must know how to do that, typically from documentation. So it needs intrinsic knowledge of the API. HateOS fixes that. The HateOS links allow the consumer to learn that functionality on the fly. Even if functionality and business rules change, client applications won't break, as they need to inspect the links they get back from the API, and these links are included in the response body. We implemented this using Dynamics. But even though we kinda have HateOS support now, we ended the last demo with a bit of an issue. We are asking for media type application JSON, but we are returning links, and sometimes even an envelope. That can't be right. So that brings us to a perfect use case for using media types correctly, instead of just returning anything as long as it's in JSON format when asking for application JSON. In the next module, we will learn all about it. Media types are an integral, if not the most important part of a REST contract. In this module, you will learn what they are and how to use them. I'm Kevin and I'll guide you through it. We ended the previous module with a bit of an issue. Are the HTOS links part of each resource representation? Or is it just one representation of a resource? It seems like the contract between client and server isn't tight enough yet. We'll improve on that, and by doing so, we will learn about advanced content negotiation with media types. We will cover vendor-specific media types on input and output. We will end by looking into an additional use case. In that part, we'll dive into one of Roy Fielding's quotes. He once stated that RESTful APIs should not be versioned. As he's the guy who invented REST, I tend to listen to him. But what does that mean? And is that even feasible at the moment? We're going to cover that. For now, let's revisit the contract. Let's dive in. Let's look back at the contract between client and server. This slide will look familiar. The contract consists of three big concepts a consumer of an API uses to interact with that API. First, the resource identifiers, in other words, the URIs where the resources can be found. That's combined with HTTP methods, like get to get resources, post to create them, and other ones we've looked into. These methods are described in the HTTP standard. The third part of the contract is an optional payload. When creating a resource, the HTTP request will have to contain a representation of the resource we want to create. When getting a resource, the HTTP response will contain a resource representation in its body. Describing the format of those representations is what media types are used for, like application JSON. But is that really sufficient? Asking the question is answering it. Application JSON tells us something about the format of the data, JSON, but not about the type. Roy Fielding, the guy who coined the term REST, has a pretty insightful quote on media types in relation to RESTful APIs. He states that a REST API should spend almost all of its descriptive effort into defining the media types used for representing resources and driving application state, or in defining extended relation names and/or hypertext-enabled markup for existing standard media types. The first part of the definition already answers our question. You can hardly say that by using application JSON as media type all over the place, that almost all effort goes into defining media types. In fact, most HTTP APIs don't define media types at all. RESTful APIs, on the other hand, should. There's quite a few scenarios that this allows. Let's start by fixing the issue we ended up with at the end of the previous module.